In this video, we're going to look at addition reactions in which multiple products can form during the reaction. Our first example is going to be the addition of HCl to 2-methylpent-2-ene. So we're going to start by drawing 2-methylpent-2-ene. So we have a 5-carbon chain with a double bond between carbons 2 and 3 and a methyl group on carbon 2. We're going to add HCl, so I'm just going to do this in a different color, HCl to this compound. Now the reason that we can form multiple bonds or multiple products here is that we have different carbons on either side of our double bond. So one carbon, we'll call this C2. C2 has a methyl group and is one carbon from the end of the chain. C3 has no methyl group, is unbranched, and is 2 carbons away from the end of the chain on either side. Because these carbons are not the same, substituting the chlorine on either carbon will give us different products. So our first product, if we substitute the chlorine onto that red carbon, I'm going to do the chlorine in red this time. This product is going to be called 2-chloro, 2-methyl, pentane. If we substituted that chlorine onto the green carbon instead, we would get 3-chloro, 2-methyl, pentane. So we get isomers as our products. Our next example will be looking at the hydration of 3-methylcyclopentene. So we're going to start by drawing cyclopentene. So cyclopentene is a 5-carbon ring. It's a pentagon. It doesn't really matter where we put the double bond. It will be carbons 1 and 2, and so carbon 3 will be 1 carbon away from the end of the double bond. When we are hydrating a molecule, we are adding water. So we're adding H2O to our molecule, which I'm going to write as HOH, just so that we remember we're adding hydrogen to one side of the double bond and hydroxide to the other. Whenever we react an alcohol, we always need a strong acid catalyst. So there are 2 possible options for products here. So I'm going to highlight our carbons again. So I'm going to highlight one carbon in red and the other carbon in yellow. These carbons are not equivalent. So what that means is that this red carbon is 2 carbons away from a methyl group. This yellow carbon is adjacent to a methyl group. So if we substitute the hydroxide on either carbon, we'll get different products. So we're going to start by substituting the hydroxide onto the red carbon and the hydrogen onto the yellow. So we'll draw our cyclopentane. We'll get rid of that double bond, so we'll keep our methyl. So in this scenario, our hydrogen is going to go onto our second carbon. We're just not going to draw the hydrogen. And our hydroxide will go onto the top carbon. This will give us the product. So remember, when we're naming alcohols, the hydroxide gets number 1. So this will give us the product 3-methylcyclopentanol. If we substitute the hydroxide onto the yellow carbon instead, we will get a different product. So again, same starting position. This time our hydrogen is going to go onto this top carbon and our hydroxide will go here. You'll notice that our hydroxide is directly next to our methyl group. So this will now be called, because our hydroxide is number 1, 2-methylcyclopentanol. Our final example is going to be our trickiest yet. So here we're going to look at the addition of excess HBr to propyne. And the reason that we have excess here is that it means we have more than 2 moles, so we can completely react that triple bond. So we're going to draw propyne, and I'm going to actually draw the carbons out because it's a little bit tricky. And we're going to do this in 2 steps. So propyne is a triple bond between the first 2 carbons, hydrogen on the end, and then a methyl group on the other end. So this is propyne. We're going to add our HBRs one at a time because it's going to be quite involved to figure out how many different products we can form. So our first addition of HBr, I'm going to do in blue, so HBr. There's 2 possible products that we can form. One product is going to be putting the hydrogen on the terminal carbon, so HC double bond C. So with the addition of only one mole of HBr, we don't get rid of the triple bond, just one of the bonds, so we still have a double bond left. All right, so now what we're going to have is we're going to have a hydrogen on the end and a bromine on the second carbon. Another possible product we could have is if the hydrogen went onto that middle carbon and the bromine went onto the end carbon. These are intermediate products. So each of these can further react with another HBr. And so if we look at our first product, we can form 2 new products from this. So in one, I'm just going to keep drawing kind of our parent chain here. So we have our parent chains drawn. So we're going to start with that product we formed in the first product we drew. So HBr, bromine in the middle. When we add our second HBr, the bromine can go in the middle again, or the bromine can go on the end. So we get 2 different products. And we're going to name these now. So the first product is going to be 2,2-dibromopropane. And the second will be 1,2-dibromopropane. If we start with our second product, that is this product where bromine was already on the end, so I'm just going to draw the kind of skeletons of those. What we can do is we could put the bromine on the end again and the hydrogen in the middle. I won't show the fourth product because it actually ends up being the same as this product, where the second bromine goes onto the center carbon and we end up with 1,2-dibromopropane. But the name of our third possible product is 1,1-dibromopropane. So you can imagine an example where you have multiple double bonds or multiple triple bonds in a molecule, how complex the distribution of products could be if you're adding excess reagents of either water or a hydrogen halide.